is fx is equal to minus pi for minus pi less than x less than or equal to 0, and is equal to x for 0 less than or equal to x less than pi. A0 is 1 upon 2 pi integral minus pi to pi, the range is minus pi to pi, fx dx will be 1 upon 2 pi integral minus pi to 0 fx dx plus 1 upon 2 pi integral 0 to pi fx dx equal to 1 upon 2 pi integral minus pi to 0. In minus pi to 0 fx is minus pi, so minus pi dx plus 1 upon 2 pi integral 0 to pi. In 0 to pi fx is x, so x dx. So this will be minus half, pi is taken outside, integration of dx is x between minus pi to 0, plus 1 upon 2 pi integration of x is x square by 2. So this will be minus half, upper limit value is 0, lower limit is minus of minus pi, plus 1 upon 2 pi, at upper limit it is pi square by 2, at lower limit it is 0. So this is minus minus plus and again minus, this is minus pi by 2, and this will be 1 pi cancels, so it will be plus pi by 4. Ultimately this comes out to be minus pi by 4. So A0 in this case is minus pi by 4. Let us find AN. AN is equal to 1 upon pi integral minus pi to pi fx into cos nx dx will be equal to 1 upon pi integral minus pi to 0 fx into cos nx dx plus 1 upon pi integral 0 to pi fx into cos nx dx will be equal to 1 upon pi integral minus pi to 0 minus pi cos nx dx plus 1 upon pi integral 0 to pi x into cos nx dx. So this will be minus pi by pi. Cos nx is integrated as sin nx upon n within limits 0 minus pi to 0 plus 1 upon pi. This is to be integrated by generalized parts. Retain first x, integration of cos is sin nx upon n minus differentiation of x is 1, sin ka integration minus cos nx upon n square within limits 0 to pi. So it will be minus 1, at upper limit sin 0 is 0, at lower limit sin n pi is 0, so the term is 0, plus 1 upon pi, at upper limit sin n pi is 0, first term is 0, second term is minus minus plus cos n pi is minus 1 raised to n upon n square, minus at lower limit sin 0 is 0, second term cos 0 is 1, minus minus plus, so it is plus 1 upon n square. So ultimately we get it as first term is vanishing, plus 1 upon pi, it will be minus 1 upon n square minus 1 upon minus 1 raised to n upon n square minus 1 upon n square. So it is 1 upon pi n square into bracket minus 1 raised to n minus 1. That is going to be value of AN. So AN comes out to be 1 upon pi n square into bracket minus 1 raised to n minus 1.